Hi everyone! In this video, we want to show you how Adswerve were able to run SQL on images and build machine learning models using BigQuery ML. My name is Candice Chen. I am the product manager for BigQuery at Google Cloud. It's my pleasure to have Pat Grady to join us today. Hello, Pat. So great to have you. BigQuery is an enterprise data warehouse for analytics. Historically, it's known for analyzing and governing structured data. But today, we are going to learn use cases beyond that and understand how we can use both structured and unstructured data and bring it together. Then you build machine learning models on top of that. So before we get started, Pat, do you mind introducing yourself and tell us a little bit about Adswerve?
Yeah, absolutely. So my name is Pat Grady, and I'm a solution engineer and technology evangelist over here at Adswerve. And we help businesses leverage data to improve business outcomes. And so we primarily do this by focusing and solving marketing and digital activation use cases.
Great. I know in this project, you also work very closely with Twiddy. So can you tell us a little bit background about Twiddy and how you work with them?
Yeah, absolutely. So we've been working with Twiddy for a number of years. They manage vacation rentals in the Outer Banks of North Carolina, and we've been helping them measure their website with the goal of improving guest experiences. So we've also been helping them develop capabilities directly within BigQuery ML, which actually led to this latest project.
Awesome. Yeah, I'm curious to know what are some initial motivations or like problems that you face that made you start this project?
Yeah, so we've been using tabular data or structured data in BigQuery for quite some time with Twiddy, and but we've not included their library of unstructured image data in those SQL pipelines. So they're heavily invested in their photo content, but that team doesn't get to access the data-driven recommendations that the website team gets to enjoy. So as a result, that team is left to make adjustments using kind of manual and gut instinct.
Got it. So I'm very excited to see how you're actually able to tackle these challenges. So can I invite you to show us a demo?
Oh yeah, sure. We put one together and very excited to show this capability off. So let's go ahead and jump right in. So we're going to be walking through the BigQuery pipeline for unstructured image data using almost entirely SQL. So we'll be loading images into Google Cloud Storage, creating an object table so that we could query those images with new image TensorFlow models to get embeddings, combine that with business data to feed into a wide and deep model that's really great for any kind of recommendation or search appliance problem. So really happy to go ahead and get started. We use Google Collaboratory to help sort of tell this story. But of course, your teams can do almost all this work directly within BigQuery and a little bit of work outside of BigQuery, for example, loading your images into Google Cloud Storage. So that's really the first place that we'll start. For Twiddy, we had actually worked with about 20 gigabytes of data across 52,000 images, but really Google Cloud Storage and BigQuery can work at any scale. So whether you have a small set of images that you're working with or a very large set of images. So here you could just see a handful of pictures that we're going to be using to analyze, get predictions out of these images, out of this image data into our machine learning pipeline. So very excited to have this new capability. We're going to create a big lake connection directly to the image bucket. So we create that connection. We get a service account credential that we can use to grant the identity and access management controls, grant that service account object viewer to this cloud storage bucket. So pretty simple and straightforward access control pattern that we're following, and security is basically built in. We now create an external table that actually we could begin to start querying against. It's using that connection that we just created and secured, and it's giving us the ability to query the image metadata along with the actual image data itself directly from BigQuery using the language of SQL. So here I'm going to grab the data from that image. The only Python code that you'll see me run in this whole presentation is this little bit that I'm basically just opening an image using the byte data from the query and displaying that image. So here you can see, if for real, this is byte a picture loaded from byte data served directly from BigQuery, which is really important because now that we transition into feeding that image data directly into TensorFlow models that are served directly from BigQuery. So to get those models there, we're going to start with some default models that we're going to download directly from TensorFlow Hub. We downloaded those models. They're really good to get started with just about any domain problem. And of course, your more advanced teams will apply transfer learning and other state-of-the-art techniques to transfer the models to your actual business domain. But for getting started, these models on TensorFlow Hub are a great place to begin. So we're going to go ahead and load those models into Google Cloud Storage. Here we're getting the saved models loaded directly into Google Cloud Storage. And now that they're there, we're going to actually use our create model statements to create a TensorFlow model directly in BigQuery and served from BigQuery so that we can run our ML predict function against it. And we're going to have a classification and a feature vector model available to us so that we can now transition to generating image labels and embeddings. So this is the really exciting part for our data science team to get to this point where we're actually within just a couple minutes able to query image data into a image model that's being served entirely from BigQuery and getting to the point where we could get predictions from that. So this is really exciting capability and happy to demonstrate this to you all today. So if you're not familiar with Imagenet models, basically what's happening is you drop a picture in, and of the 1,000 or so labels that are available to the model, we're getting back a confidence that this image contains a goldfish, or a confidence that this image contains a hammerhead shark, and do that 1,000 times, and you've got yourself a pretty classic Imagenet 1K classification model. So we're going to use that classification model that we just uploaded, run a predict function against that, we'll just feed in the one image that we looked at, that we peeked at previously, grab the top 5 scores that came out of that image. So for this particular image, we're seeing labels like boathouse, patio, library, picket fence, palace, which are like, wait a second, those labels aren't super meaningful. Well, actually, when we go back and look at the image itself, we kind of say, oh, wait a second, this little gondola out here, it really has this boathouse nautical feel to it. The white picket fences are very similar to the railings. It's very common in the North Carolina Outer Banks. And then of course the patio, there's 12 patios on this property, so pick one. The library and the palace, well, the 24 bedrooms of this palace, I'm sure one of them is next to a library. So actually this default model did a really good job with our specific vacation rental business domain. I'm sure it will do really well for some of your business challenges as well. Now, that was the toy problem. Like, we're not building a classification problem for vacation rentals. We were building a prediction engine to get the best image in a given search result. So to do that, we need to take those embeddings and those labels out of those images and combine that with our search appliance data. So our Google Analytics telemetry, our search appliance telemetry, combine those in a wide and deep model, which is going to be really good for any kind of like recommendation or custom search appliance or any type of ranking problem that you have. This pipeline is going to be really good to follow. So, speaking of pipeline, we like to use BigQuery's stored procedures to turn our queries into parameterized functions that lets us really control the flow of our training and really kind of create a DAG, a directed acyclic graph, to make sure that our pipeline is running with all the prerequisite steps. And so we use the procedures to manage this and ultimately get to the point where we have a trained model. It's actually highly accurate. We were very impressed with the results of that wide and deep model, and get it to the point where we can then productionize it and actually run queries against it. So once we're to the point where we can run queries against that brand new model that we trained, then that's really when we get the value. We can learn from the results that are coming out of that, and then actually implement those learnings into the website experience directly, or at a high level into the editorial strategy from those teams. So we can look at that in just a second. But here I just ran a simple prediction. I ran some of the images plus the search data through this wide and deep, and got back some probabilities to click for those given search contexts. So we'll go ahead and step out of it and back over to Candace, and we'll talk about the results and the learnings.
Yeah, Pat, thanks so much for the demo. Well, I have to say, I love the house photos, super impressed by 24 bedrooms. I think I'm going to work on my next vacation home. But jokes aside, so I was super impressed by how you were able to draw some really useful insights from those house images and then use that in a machine learning project. So now I wonder how Twiddy is planning to use those results.
Yeah, so using the explainable AI features of BigQuery and running functions like global explain against that model that we trained, we actually get to learn what the model learned, which the big insight here that was that how important the images are to the prediction itself. So that was really fascinating to see. Our data science team thought that they would be important. We know that images are important in the search experience, but to really have a quantity behind that was really cool to see. The next thing was then aggregating the predictions kind of globally and looking at those results, which gives us insight into this sort of high-level photo editorial strategy. And so if we just take the prediction, the performance of the individual labels that were showing up in all those different in those images, then we kind of get this really cool scatter plot that is really informative to an editorial strategy, telling us to do more of swimming pools, keep up featuring water and blue skies, put less stairs in the pictures. And when we reviewed this with the photo editors at Twiddy, they were really excited and thinking about how they were going to start framing their shots and making adjustments to the way that they take pictures and feature pictures on their website. And then as far as featuring pictures on the website, we can actually use the predictions to very quantitatively identify opportunities for us to feature a better image where there's a low performing image at play now. So, in this particular example, I show some examples where, on the left column, those are actual images that are being featured now. And we identified through the model some other images that might perform better. And they might be counterintuitive from an editorial perspective, but the model is saying that we should try it out. So we have a nice hypothesis going into a good A/B test to actually test and get the value out of that. So that was really exciting.
Yeah, that's super awesome. So just to summarize what we learned from you so far. So starting today, you can run SQL on all of the images and then build machine learning models by using BigQuery ML. And then we also learned that you can combine both your structured and unstructured data in one place where it can help you largely improve your machine learning model performance. And then lastly, most importantly, we can also drive important insights from those unstructured data that can help business like Twiddy to make better business decisions. So what a great story. For anyone who's interested to try out this feature or any other BigQuery ML capabilities, please sign up this interest form, and then we look forward to working with you. Thanks everyone for joining.
Thank you.